So still no crank. Let's look at the codes in the ECM. No DTCs. Transmission controller. No DTCs. Should we look at the live data? Let's see, transmission data. I just want to see, like, what does it know what gear we're in? Engine speed, ignition voltage, transmission range sensor, ABCP. No comm. What is going on here? Do we have loose pins at the DLC? This makes zero sense to me. How about with no scanner plugged in? Okay, obviously no crank. That's fine. Let me tighten up the pins at the DLC so we don't have to mess around with the scanner, you know, Bluetooth dongle. Those pins are kind of spread out too. And then do a rescan. So at the DLC, all you want to do is get, you know, one at a time, get out these pins and just press on top where that spring is, and then use a needle probe to drag check that terminal. See, that's nice now. Before it was completely loose. So put this one back in, clip that in. There's only 6 pins on here. Let's do all of them while we're here. So this is the power wire. Be careful that your pick doesn't touch anything metal while you're extracting this pin. We'll push this down right here. Check it with our needle probe. Oh, that's still pretty loose. Let's depress it a little bit more. There we go. See, that should hold the needle probe in there just fine. We'll put that back in pin 16. And then let me buckle that back in here. Now let's take out the top retainer. Come on. I'm being a little stubborn. Well, let me get that out. Tighten up all the other pins and we'll try again. Alright, so after tightening all the pins, did another code scan and everything is back online. Clear out all the DTCs right now and see if anything comes back. Okay, fuel pump control module, transfer case control module, EBCM. Okay, we don't care about seats. We don't care about rollover sensor. So let's back out. Key off. Let it go to sleep. Kind of a reset. And then our Prindle works. We're in park. Try to crank it. No crank. Now let's do a smart scan again. Green, 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 green. So now we're going after the starting system. Let's find the starter relay, wiring diagram, do some basic checks. Okay, so here's the OE diagram for the starting system. There's the engine control module. Here's our ignition switch. So when we turn it to crank, the BCM should see a crank input. So we'll check that with the scanner. Then that talks to the engine control module, and then engine control module checks if you're in park. We have this transmission here. So just a park neutral safety switch. We can look at the data, see if it thinks we're in park and neutral. And then it finally controls the starter relay. So power side switched, that's grounded, and that should send power to our starter. We can see if the ECM is energizing the starter relay. So let's look at some data on the scanner. Alright, let's hop into BCM. See if there is a start request, data stream, and power mode. That's what we want. And we'll just select all. Okay. So we're in run. Accessory is on. Ignition is on. Key is in. Run relay is on. Run crank relay command is on. Current power mode. So let's turn it to crank. Let's see. Let's turn it back to accessory. Accessory back to on. Run. I'm going to hold it in crank. Crank request. Excellent. Okay, so BCM seems to be happy. Let's go into the ECM and see what the ECM is doing. Data stream, electrical theft data. So there's a crank request signal, park neutral position switch. Let's see what the brake pedal is doing. Ignition accessory signal, ignition 1 signal. Fuel enable, fuel disable, starter relay command. Okay, let's look at those. Let's graph that. So starter relay command, if we turn it to crank, on. Crank request, yes. Okay, very good. Now we need to go to the starter relay and see if the ECM is actually clicking this relay on. Okay, fuse box. Starter relay is right there next to the little AC compressor relay. That's this guy right here. Let's pull that out. Pins 30, 87, 85, and 86. So we know which pins to test. Let me get some adapters. We'll do some basic checks with a test light. Alright, so I put the adapters in pins 30 and 87. I don't know which one's which, but we only have four pins. So from the alternator, I'm grabbing battery positive. If I find the ground, test light's going to light up. So one of these should go to the starter and be grounded through the starter solenoid. It's not that one. Well, it's not that one. Let's see if we can find a power here. Make sure our test light works. So if it finds a power, it's going to light up. Let's see if pin 30 is hot all the time. One of these should be pin 30. It's not that one. And okay, it's that one. That's pin 30. This lower right corner. That pin is not being energized, or I'm sorry, it's not continuous through the starter solenoid. That's a problem. Now, let's put the adapter in the other two, and we just put a test light across here and crank it. If that test light comes on, we know the ECM is powering up the starter relay. Alright, so I've got the test light connected across the control pins for the starter relay, and let me crank it. Yes, and it'll de-energize it. Boom. So that's it. We found the bad pin. That's the one going to the starter. How fast was that? And we know exactly what we checked. Now there are some devices out there that are supposed to save you time. You know, you plug it in into the fuse box, has a whole bunch of adapters, and you can do this and that, measure voltage and current. Guys, you don't need any of that. And those tools, you know, you think it makes it easy, but it doesn't make you think. This wiring diagram, a couple adapters, a test light, a voltmeter, amp clamp, whatever you need, you can do all the checks in probably less time than even finding the right adapter, and you know exactly what's going on. So that's why I don't try not to use specialty tools, you know, power probes and load pros and all that stuff because you don't need them. You know, the more basic the tools, the better you're going to understand the circuit. So this pin right there, we have no continuity to the starter solenoid. We can try to find the starter, see if they've been messing with that, and you know, it might be a bad starter or at least a bad connection to the starter. Well, that's a problem. The starter is completely disconnected. The control wire is hanging out, and the main positive wire is hanging out right above there. We could have had a major short circuit here. Holy crap. You can see the nut on the solenoid's off. What the heck? Why would they do that? Alright, let's disconnect the battery before anything bad happens. And I'm going to try to reconnect all this stuff at the starter solenoid. I'm hoping this thing will crank over and fire right up. Well, more bad news. The little control pin or stud on the solenoid back there is snapped off. So whoever messed with the starter, I don't know if I can even get a shot of that in the mirror. It's snapped clean off. There we go, almost. You see the main post, but the little control post with an 8mm nut, it's MIA. You guys won't be able to pick that up. There you go. This just snapped clean off. So this is going to be a beached whale until we put a new starter on here. Oh, dang it. So close. So I'm going to talk to the customer and get that authorized, and then we'll be right back. Well, good thing the starter is easy to remove. Just 2 bolts, it drops right out. There's our problem. Corrosion, and that's just snapped right off. So yeah, that's looking kind of crusty too. So he just needs a new starter. We'll get one coming and pop it in. This thing should fire right up. Alright, we've got a Reman starter here. Benchmark brand, not my first choice, but it was readily available. So let's ground test it. I'm just going to feed battery positive voltage to here. Just got jumper cables coming off the XL7. Here we go. Looks good. Let's pop it in the Chevy. Alright, replacement starter is in. Our battery's been charging this whole time, 7 amps. So let's reconnect the negative cable. Stop the charger. Disconnect that. Pop on the negative battery cable. There we go. Tighten that down, and this thing should fire right up. Alright, let's go. Place your bets now. Is the big Chevy gonna fire right up? I think it should. Wow. Smooth startup. It doesn't even sound like it sat for 4 months. Beautiful. We're doing well on our voltmeter. Change engine oil soon. Alright, well, let's take it for a spin. Make sure it doesn't set any codes. Amazing. Oh, let's see here. Look. The D, 3, 2, and 1 don't show up. Neutral does, reverse does, park does. Well, let's see if it goes. It's definitely not a beached whale anymore. That's good. It says check tire pressures. Let's check the tire pressures and then take this thing for a spin. Rescan it for codes. I don't like that it's not showing up on the gear display there. I don't know. Oh, there's 1, 2, 3, D. Okay. Okay, that came back to life. That's good. Let me pump up the tires. Alright, it's a little happier now. Let's check the, 0% oil life remaining. That's not good. Tires, I've got them all to 35. It's a little squeaky under the hood. Let's see what that's all about. Maybe an old belt. There we go, that's a little better. Little WD-40 never hurt anyone. Let's take it for a drive. Alright, so I just want to make sure that if we shut it off, will it restart, because we don't want to get stranded somewhere. Just fine. Just got the squeaky belt. Alrighty, let's take it for a rip. Alright, make sure it shifts through all the gears. 2, 3, 4. Make sure it locks up, but it seems to be pretty happy. Try the cruise control here. Yep, cruise control works. That belt squeal makes it sound pretty awful, but drives just perfectly fine. Needs an oil change and a belt. So we're back to the shop and rescan it for codes one more time, make sure it's good to go, and ship this beach whale. Alright, so what I don't like is sometimes the Prindle indicator just goes blank, like the D doesn't light up. Sometimes it's fine. See, 3, that's fine. D. That little line disappears once in a while. I don't know, maybe it just needs to blow out the cobwebs. Alright, let's scan this thing for codes one more time. I've noticed that on GMs, especially GM trucks, these scanners sometimes cause communication codes, like the dash will light up for a second and then you'll have all these communication codes stored. So we'll see if that happens. So you do automatically search. Yes. Okay. Okay, I guess it went through fine with it that time. So let me get in here, do a full code scan. We'll see if a code is stored for the Prindle, position. But otherwise, the truck is done. Nope, no new codes stored whatsoever. I don't know what that's all about. We can clear the rollover sensor code. Okay. That's happy now. Memory, seat module, lumbar, vertical position sensor. Don't care at all. So I think this thing is ready to ship unless the guy wants a belt and an oil change, but I would say maybe the other shop that had it for 4 months can give him a freebie, oil change and a belt, because, just common courtesy, right? So yeah, this one wasn't, classic can open circuit case study, nothing crazy. But the process here is key. The diagnosis wasn't hard, but if you have no idea what a network is, how it works, how to check it, then you're gonna end up replacing modules, tearing up harnesses, this and that, for no reason. So hopefully this video helps people out, and that's it. Thanks a lot for watching, and we'll see you in the next one. Bye bye.